Okay, so let's begin our survey. Who here in this room actually knows what the word electromagnetism means? What about you, Jeffrey?
No.
Okay. Okay, so as you can see, not many people in this room knows what it means, but it is actually a really simple branch of physics that just talks about the interaction between electricity and magnetism. So there are two core scientific principles to electromagnetism, and they are that electricity produces magnetism, and conversely, magnetism produces electricity. So these two principles are fundamentally connected, although there are still different aspects of electromagnetism. So throughout the history of electromagnetism, there have been three stages in which important discoveries were made. And the first one was made by O.S. Third in 1820 when he discovered the magnetic effect of current. So when he realized that a current was flowing through an electric wire, it was able to divert and deflect a magnetic needle. And it's a known fact, and it was at that time, that magnetic needles were only deflected by magnetic fields. So he deduced that the electric current must have produced a magnetic field that was able to deflect the magnetic needle. So at the same time, Andre Marie Ampere he had this theory, and he said the same thing, that electricity could produce magnetism. And this paved the way for the electromagnet. So as you can see, it says right here that electricity produces magnetism. And it's true because there's a dry cell here, and it produces a current, and it is able to magnetize this iron core. And also one interesting thing is that when the flow of the current changes direction and goes the other way, the poles of the magnet actually change as well. So the north pole becomes south pole becomes north pole. And also it's a temporary magnet, so it's going to lose its magnetic properties after a while, because it's just a simple electromagnet. So a decade later, Michael Faraday and Joseph Henry both discovered electromagnetic induction. And it is basically the second core scientific principle. And the first one was that electricity produced magnetism, which I just talked about. And this one states that magnetism produces electricity. Because Michael Faraday ran a lot of experiments because he was interested in electromagnetism. And when he placed various substances in pans, he realized that it could actually create vibrations on the board itself. And some other vibrations on other boards were able to function because of the vibrations on this board, which is the basis of the idea of induction. So this led to his discovery of the electric generator. So this is the main core scientific principle he came up with along with Joseph Henry, which I'll talk about later, that magnetism produces electricity. And this is basically a really heavy copper disc, and it's attached to an axle, and when it spins, it's able to generate electricity because it is rotating through the different strengths of the magnetic field. It's because a magnet is stronger and it's strongest at its poles, it becomes less powerful when it goes towards the center. So when it rotates, it goes through different strengths of the magnetic field, which is able to produce electricity. So Joseph Henry also discovered self-induction, which is when there's a break in an electric circuit, and it leads to a waning magnetic field. And when there's a less powerful magnetic field, the current changes direction. And that was what Joseph Henry found out. So the final breakthrough occurred in 1864 when James Clerk Maxwell discovered that electromagnetic waves have radiant energy. So the whole idea of electric and magnetic fields working together in sync was thought up by James Clerk Maxwell. And 20 years later, in 1884, this German scientist called Hertz also proved Maxwell correct, when he found out that there was such a thing as electromagnetic waves in the world. So electromagnets play a really important role in today's world because really powerful and large electromagnets are used in scrapyards to pick up items, and also electromagnets can be found in doorbells and also electric motors, and also small-scale electromagnets are also used around the world. It is the force which binds protons and electrons together in atoms, which are the structures of molecules. And so as you can see, electromagnetism has a really important role to play in our lives, and I hope that this presentation has kind of taught you about why it is so important and how it is used in today's society. Thank you.